Awesome. Thank you, Lindsay, for introducing me. So yeah, as Lindsay mentioned, there's Q&A and chat. So at any point, if you have a question, post it in the Q&A. I'll keep an eye on them during the session as well, so that if there's any questions, we can always tackle them at once. From my side, welcome as well to building a friendly .NET SDK to connect to JetBrains Space. The idea of this talk is to walk you through, first of all, our product, to give you a little bit of an idea of how big it is, what is all in there. And second of all, to walk you through how we thought up the design of building the SDK that you can use as a .NET developer for working with JetBrains Space. And I should find my screen. It's almost like we'd never present remotely. Anyway, here we go. So let's talk about JetBrains Space first a little bit to give you a little bit of an idea of what the product is like and how you can get started with it. So JetBrains Space, and I promise this is the only marketing slide of this entire talk. JetBrains Space is an integrated team environment, which means that you have people and teams who are working in your organization. They can collaborate on projects and workspaces inside of Space, and all of that information sort of flows together and is available. What we mean by that, by the fact that it's an integrated team environment, is that in the people aspect, you have vacation tracking, you have absences, you have a calendar and things like that. The idea is that all of those things should also be visible when you're working on, for example, a merge request in a Git repository in Space. So imagine I write some code and someone else on the team wants, or I want someone else on the team to review my codes. By having the people and team aspect inside the same environment as your entire Git hosting and project management sites means that I can immediately see who on the team is available for a code review and who is not available. Now, I promise this is the only slide on that topic. I will quickly show you what it's like. I will probably also rush through this because Space is huge, and the general idea is that I want to show that there's a lot of things in there because it actually matters for the rest of the presentation. So this is Space. I created an organization called demo.jetbrains.space. I thought this is a very cool URL to register beforehand, so that's mine now. This is demo.jetbrains.space for an organization called Galactic Travels. And every user of Galactic Travels has a homepage here where they can see their agenda for today. Pretty boring because there's only stand-ups in there. I hope at some point there's going to be other meetings and other stuff in there as well. There we go. So apparently there's an Easter Monday on Mars at some point, and a colleague of mine has a birthday in there. I can see people that I work with and follow, and immediately see whether they are at work, whether they are available or not. So all of that information is visible at a glance. My favorite projects are there, so I can start working with a specific project. If I have code reviews that are open, and actually it seems that I have a couple of code reviews open, I can immediately see whether I should look at them or not, because these need my attention. There's also recent blog posts, so information can be shared in Space where, for example, you can send a message to everyone in the organization or only to people in a certain office or at a certain location or in a certain team. So for example, if we all return to the office and you want to do a fire drill in one of the offices, well, you can write a blog post about that, target it at one office so that everyone else in the organization is not disturbed by getting that message. Inside of a project, you'll see that there's documents where you can keep track of sort of a knowledge base. You can write about how you do code reviews, for example. There are checklists where you can see in a high level which tasks have to be done. You can move those things around using the keyboards. You can, from that checklist, create issues and assign them to people. If you go to the issue, you will get more information. There's a due date in there, tags, checklists. You can add them to boards as well. So if you go to the issue boards, you'll actually see in swim lanes what is available and what the status of every issue there is. There are repositories. So we have some Git repositories in there. As you would expect, they have commits. They also have a file browser where you can see all of the files that are available in a specific repository. Kind of nice, at least one of my favorite features in Space there is that inside of codes, people can add comments and start chatting about things. So for example, if in this content.kt file, I have a question about what this specific statement means, I can ask the team, and the team can start responding from a chat that is part of Space. There's code reviews as well. So I can open a code review. I can ask my colleagues to review. They can respond to that as well. They can see it from the code review window here, but they can also work with this again from chat, because everything in Space is also a chat. There's jobs in there, so you can run CI/CD and build your codes based on a script that you write, and that will essentially do your entire unit testing and deployment and whatever you want to do there. There are packages that can be Docker images, that can be Maven repositories, can be NuGet feeds, can be NPM registries, etc. There's some settings on every project where you can say, for example, who is responsible for a certain subsystem, so that anyone who joins the team can quickly see, okay, for updating documentation, for example, this is the colleague that I want to talk to. If you click their profile, you will see their profile image, profile card. If they have a vacation, you'll immediately see that. So again, that's the integration of people and teams inside of the work that you're doing. Everything in Space can also be a to-do. So if I have an issue here, for example, and I will have to follow this up at some point, click the lightning bolt icon, and this will be added to my to-do list on the left that is always available. So there's a couple of issues in there. I can remove it as well. If I have issues or if I have to-do lists from my own, I can do, for example, a Visug presentation, add that to the to-do lists, then postpone this until tomorrow, for example. Or if I want to work on this thing, I can create a meeting and block time in my calendar from here. Again, having that integration, having a calendar available is kind of nice there as well. There are chats, so you can chat with teams, you can chat with people using direct messages. As I mentioned, code reviews are also shown inside of a chat. So inside the chat, I can immediately see all of those things. Blog posts are shown. Blog posts themselves also have comments. Those comments also show up in chat here. What else is there? There's a team directory where you can see all of the teams that are inside your company. If you want to organize a meeting with the team, you can look at the calendar, see who's available when, or when everyone's birthday is, or whatever. All of those things are shown in the team calendar there. Makes it quite easy to figure out who to talk to. There's global documents as well, where you can sort of build your own list of documents that you want to store. So for example, if you're working on a draft for documentation or something like that, you can add that there, just like in Office Online or in Google Docs and things like that. I know this is really rushing through it, and this is only scratching, not even scratching the surface of what Space is, but I hope that you realize that there's a lot of things in Space, and having a lot of information in Space makes it more valuable after a while. All right, back to slides. Space is massive, and we think it's still not massive enough in terms of a product and a platform. It's an integrated team environment, and having more information in Space means that there's also more value that you can get out of Space. We have some integrations out of the box. So for example, vacations are shown in your profile. You can target blog posts to a certain theme and location. There's calendar integration in blog posts. Everything can be a to-do item. Lots of integrations out of the box, but what's with external integrations? What with extensibility? Essentially, what do you want to build? We don't know. Maybe you want to write something to import data or post to a chat whenever something happens on an existing CI system you may have. Maybe you want to manage users and locations using some software that you're writing. Maybe you want to get some data from projects and issues and show that on a dashboard somewhere. We really don't know what you want to build or might want to build. So we decided to open up everything that you can do in the UI. We decided to open that as an HTTP API as well. And I'm probably going to do some tongue twisting on that, because speaking about the HTTP API playground, it worked first time, is something that's that will happen quite often during the rest of this talk. So you'll hear me stumble over that one. Anyway, there's a large HTTP API. Second time it works. We'll get there. There's a large HTTP API, and there's a playground where you can also explore what is possible in Space. And let me quickly demo that so you get an idea of what is available there. So in Space, You can customize this sidebar, and I actually added the HTTP API playground by default. So you can go in there and see all of the APIs that are available. I'll quickly collapse some of the modules that you'll find here, but you'll see that all of the modules in Space have at least one API available, and typically anything you can do through the UI can be done through Space API here as well, or through the in this playground, or using the actual API as well. Let's, for example, search for getting a profile. That's something that you may want to do. So there's a get profile API. If you look at the APIs, you'll see that the API playground gives you what permissions will be checked, and also allows you to build the request that is there. So I can get my profile, for example, profile me. If I execute this, I will get back my profile information. If I pick a username, for example, I can actually select a profile, and that will build the request where I can see what the URL looks like if I want to request this specific user, execute it, and get back that information as well. There's also, in the response here, you'll see all of those checkboxes. Space, by default, gives you a lot of information, and having a lot of information in Space also means that there's large payloads in terms of responses. We typically recommend that you essentially check the fields that you want to retrieve. And by doing so, you can actually shape the response pretty similar to how you would work with GraphQL, for example, essentially reduce the payloads and just get the information that you need in your API. There's some other stuff as well. If you want to send a chat message, for example, you'll see that you can send a message. But the request builder is slightly more advanced in this case, because you can actually build a message that is text, say hello, for example, and I can send this to a channel or send this to a specific member, for example. Send it to me. I can send hello, and you'll see that this is the request that you can build. There's also going to be a UI preview of what the chat message looks like. In this case, it's not very interesting, but you'll see in the API, if you start adding sections, for example, and say that there's going to be some text in there, blah, blah, blah. And let's say there's also going to be some fields in there, and this is going to contain a table or something. You'll see the request builder also update the preview of that chat message. So the HTTP API playground gives you a good idea of what APIs are available and what requests may look like. But this, of course, is not yet ideal and not something everyone will start working with. One side note, and I didn't really show this, what the request looks like, but it's probably easier to see this on slides. So I mentioned that in the response builder, you can select the fields that you want to retrieve from Space, and that is done through a fields query parameter. By default, all of the top level fields are returned by Space. So if you would get a project like on the slide here, you would typically get ID, whether it's archived, you would get description, things like that. But if you want to get, for example, all of the issue boards in a project and get all of the columns and swim lanes and so on, you will have to be specific and actually decide which fields you want to retrieve from Space. What that request or what that query parameter will look like is something like this, where you can have fields, just listing the fields separated by a comma. If there's subfields, so parts of another object, you can add a bracket there and then add the properties of whatever is in the brackets. There's a couple of other rules that you can do to define what the shape of the response should look like. But ideally, since we are building an SDK for Space, this is not something that you should really know by heart, how to format this fields query string parameter. Let's talk about building an SDK. So you've seen by now that the SDK is huge, or at least the HTTP API surface is massive. And we wanted to make it easy for .NET developers to actually start working with Space and build their own integrations with Space. So the idea was, to provide a ready-to-use SDK that requires minimal configuration, makes a lot of things as discoverable as possible. So for example, if you install the NuGet package for this SDK, it should be very straightforward for you to send a message to a chat channel, for example. What the SDK, the ultimate goal of the SDK would be is leading you into the shortest path to success. Now, how could we do that? Well, we started to think maybe we should handcraft everything so it really feels like a .NET SDK and everyone feels at home with it if you're doing C#. Well, no. Right now, I think, because this slide is slightly outdated, I think we have over 170 endpoints by now. There's over 800 object types in there by now. And since we just released a stable version last November, we've had last year where we were developing the SDK, where there would be a lot of churn, where fields would still change, where operations would appear or disappear, things like that. So Handcrafted was definitely a no-go. Now, you may have seen as a small link in the HTTP API playgrounds that there's also an OpenAPI document that you can download. And using NSWAG, for example, you could generate an API based on that OpenAPI documents. Now, we started going this direction, and we quickly found that it works, but it doesn't feel like a proper C# API. It still feels like just essentially bringing HTTP calls into a C#-ish sort of language. We also found there's a couple of object types that would need custom code generation using NSWAG because they are slightly more complex than the default OpenAPI specs that are implemented in there. And doing so actually made us realize, well, if we have to generate codes using some custom code generation anyway, maybe we should just skip the OpenAPI step and just use whatever model we have internally and generate our code from that, which is what we did in the end. A quick other example of how OpenAPI is not ideal here. If you would, for example, want to get all of your vacations, OpenAPI or NSWAG would generate something like this that says get absences async, then a string fields. This is that fields parameter on which properties you want to return or get returned from space. It will also accept a body, which would hold all of the parameters that you could give to it, but still it feels like it's almost like this API would invite you to craft your own JSON and just use the HTTP call directly anyway. This is very not ideal and not very friendly for developers. Now, in terms of custom code generation, it turns out that Space actually exposes the entire HTTP API model in the HTTP API playground as well. So if you craft a request like this, where you get the HTTP API model with fields, DTO, enums, URL params, and some other stuff, you get back all of the types, all of the enumerations, all of the DTOs, all of the potential calls that you can make in Space. You get those back on an API. I'll actually quickly show you what it looks like. So if you search for model, you can get the HTTP API model, and from there you will get everything. So that's a very long list of fields and so on. We decided, by the way, for the default values that are returned in this API, you actually have to be specific. So if you want to get all of the classes and their fields, you will actually have to specify that I want to get all of that information with field names, with whether they are optional or not, what types they are, etc. And then Space would give us, let's scroll up again, Space would give us stuff like there's a class that will hold time zones, that has a field ID that will be a primitive of type string, it's not nullable, and it's not optional. So you'll get all of that information from Space. So slightly more advanced than what we could be doing with OpenAPI. Speaking about enumerations, that's probably the simplest type that is available in the Space API. So typically, stuff like weekdays, a weekday enumeration is something that we could expose in Space, and that is going to be modeled as an API enum that has an ID, maybe a deprecation warning, a name, and all of the potential values for that enumeration. Using a model like that, we could write a code generator like this, where we have an enumeration visitor that would visit the enum and then just use a StringBuilder to generate whatever you want to do. So this one, what it will do is check whether there's a deprecation. If there's a deprecation, write the deprecation. For every enum, also write the public enum, whatever the name is, and then append all of the values. And as a result, you would get something like this, where if you want to get all of the absences, for example, you can pass in an enumeration value of absence list modes, and this is a generated code that we can generate from this. DTOs are slightly more complex. You'll see that they have an ID, they have a deprecation and name as well, but also fields. They can extend other DTOs, they can implement interfaces, they can be sealed, they can be open, there's lots of metadata in there as well. You'll also see that there's this record property. Once we start porting this entire SDK to using C#9, we will use that record property also to decide whether the output we are generating is going to be a record or a class. API fields are there as well. So for every field, we keep the name, also the type, also whether it's optional. If there's a default value, all of that is going to go in there as well. I actually see a question coming in the meanwhile, so I'm quickly going to sidestep to that as well. Is there any reason you did not choose to use GraphQL to provide the API and just avoid overfetching responses? Well, that's a good question. Space actually, or at least the API, evolved from what we've been doing in UTrack for a couple of years now. And it was a logical step to quickly craft an API that would work with the different frameworks that we have for building mobile applications and so on. So is there a reason we didn't choose GraphQL? Apart from just being able to have velocity and build Space as a project, there's no reason. So I hope that that answers the question. All right, where was I? In the DTO model, yes. DTOs are slightly more complex. I'll show you the more complex one even, and that's going to be endpoints. So if you make a request that is part of Teams, for example, you can have a team directory client in there. In that team directory client, there's going to be a profile client. Then you have methods get profile. Profile can be fetched by ID, by username. All of that is modeled in the endpoints model. And by the way, this is entirely open source, at least the SDK. So if you want to have a look at the endpoints model, you can do so. But as you can see from the drawing here, I hope you realize that there's lots of information in that model. So I'm not going to dive too much into that. What I am going to do is show this in action, first of all. So I'll use the enum example again, the enumeration example again, because that's the easiest one to go through. So to build or to generate the code for the Space SDK, we actually crafted all of these API something classes. And you'll see in the project, there's API DTO, there's API enum, there's API field, and so on. Those are all handcrafted just to be able to read the model that we could get from Space. For an enumeration, you'll see that we have the ID, deprecation, name, values, etc., etc. Based on this class, we can then essentially deserialize whatever the API gives us back and populate our model in memory and then start writing code as well. The way that works is that we have a JetBrains Space generator, a very simple console application that will take some command line arguments, and those command line arguments allow you to either specify a local dump of the entire JSON model that we have for Space, or use the URL to an API of some Space endpoint somewhere and then generate from there. If we do that, you'll see that we load the model from the API, and we do that by fetching this specific URL that gives us back all of the DTOs, enumerations, URL parameters, resources, etc., etc. We deserialize that into the API model graph. That is going to be something like this, where we again have a list of enumerations in this case that I wanted to show. And then we start generating codes. The way we generate code is by calling this execute code generator methods that will build code based on a code generation context that we create from our model. Space is entirely written in Kotlin, separate programming language. And the model is very much leaning towards Kotlin as well. So we actually use the same or similar approach to generate the Kotlin SDK for Space. Because Kotlin and C# are very much alike, it's easy to generate code for both using a similar approach. There's a couple of things that are important to actually adapt in the model that we get from Space, and that's all that's being done here in this code generation context. First of all, we create some maps to have an object ID and then what it looks like. But also we're doing some updates, for example, removing some fields that should be ignored. We are removing some common prefixes from names and so on. So there's a couple of changes to the model that we are making before we actually start generating the codes. Very minor, but important small changes to actually make it a C# SDK and not a Kotlin transpiled to C# type of SDK. We then generate all of the files based on that model, and we do that using a C# document writer, which is essentially just a small wrapper around the file stream. The reason we introduced this one is that we are also looking into source generators in C#, and we want to quickly be able to swap things out if needed. So that's why that thing is there, but it's essentially a wrapper around a file stream that we can write to. What is being written? Well, everything our C# API model generator can build, and it's going to write resources for endpoints, for all of the URL parameters that are available, for our enumerations, for DTOs, etc., etc. For DTOs, for enums, what does it look like? There's the C# API model enum generator. It's almost Java in terms of long class names. Where we generate enum definitions, pretty similar to what I showed you on slides, where we have that API enum object with metadata. We then generate a type name, write a deprecation if needed, and then start appending whatever has to come out there. Things to note here, we're using a StringBuilder. I'll elaborate on that one in a bit. We are also using extension methods, for example, to write C# deprecations, a C# class name, an identifier from whatever string value that we have. Also expand on that, but see that these things are in there. And then essentially we write whatever output to string, and then that's going to be the object on the other side. I'll quickly show you one of the enums that are available in Space, and I think there's the absence list mode. You'll actually see that the generated code is essentially what we had on slide as well. There's going to be an enum with the name that we got from the model. There's going to be some enum member decorations that are being added, and then the actual values as well. Maybe yet another quick sidestep, and there's so many of them in this talk, so sorry for that. For enums, we are writing this enum member attribute as well that allows us to reflect over the actual value. In Space, some of the DTOs actually have values like this, or all lists with underscores and so on. And ideally, we don't want to expose something like this in C#, because that would feel awkward and not really C# specific. In such a case, we actually want to write something that is more similar to all lists, but still keep the original value that we have to pass into the API later on. I'll revert that before I accidentally commit this stuff. All right, I think I covered most of this enum generator, just to give you an idea of what it looks like. So let's now talk about some of the decisions that we made in writing the code like this. So first of all, let's talk about why we are using string builders. Generally, there's a couple of ways to generate code in C#. You can do that intermediate language based and essentially use reflection emit and write intermediate language immediately. We thought that would be a crazy thing to do because there's lots of data transfer objects and it would make no sense at all to use actual intermediate language. There's some other options. There's a model-based approach where you can use code DOM or expression trees or Roslyn syntax generation, where you actually have a code model and populate that model and then write everything into files. I'll elaborate on this one a little bit later as well, but for our use case, it seemed way too complex and harder to understand. There's the template-based approach that a lot of projects out there are using. Actually, NSWAG is using something like this as well, where you have templates of what a class would look like, for example. You pass in the model into those templates, and then everything is generated on that, similar to how Razor pages work, for example. And then there's the poor man's code generation option, I would call it, strings all the way, just writing strings and populating strings and emitting those into code files. We decided to go with strings all the way, at least for the .NET SDK. For the Kotlin SDK, we are actually using something Roslyn-like called Kotlin Poets, because that thing is somewhere in between strings and what Roslyn offers you, for example. But for .NET here, we decided to go with strings. The reason for that is, first of all, IL-based would again be too complex. Model-based is too verbose, and template-based is just a bunch of spaghetti where you don't see whatever is going to happen. On the slide here, I have two examples of writing a very simple public property for a specific type with a specific property name. You'll see the string version first, which is just a one-liner and essentially almost what you would see in the generated code. So it's easy to map back and forth between generated code and the code generator if you want to browse through it. And second thing you see is the Roslyn way of doing things with a property declaration and building a model of a property, setting accessor declarations, adding a getter, a setter, and things like that. It's all there, it works. It's super handy to get references to a specific class or a specific property and so on, but it's much, much more verbose. And up until now, we don't see the need for going into this type-safe way of generating things, and strings are just working fine. I talked about those extension methods as well. So we're using extension methods pretty much everywhere in the code base. You'll see whenever we need a class name, for example, there's going to be an extension method. Whenever we need a variable name from an identifier of an object in the model, we'll have an extension method for that. Reason for that, and I'll quickly jump to the IDE for this. If you look for example, to C# class name as symbols, you'll see that we have a 2C# class name on DTO, but also on enum, but also on URL parameter and on endpoint, etc., etc. Reason for those extension methods is that not every type of object has a class name representation, for example, but working with these extension methods still gives us a way to uniformly make use of a method to get a class name, for example. So we know if we're working with a DTO, when writing the generator, we know that there's going to be a 2C# class name method that can be called. All right, let's talk about one of my favorite libraries nowadays, System.Text.Json. When we started building this entire SDK, we were deciding, because that was just before .NET 3.1 was released, we were thinking whether we should be using Newtonsoft.json or System.Text.Json for all of the deserialization and serialization needs. Reason why we were in doubt there was that Newtonsoft.json is an additional dependency, and if we would take that dependency, then your project in the end would also have to take that dependency. But with .NET 3.1, there was also System.Text.Json, and the idea was, well, that's in the framework. Maybe if we start using that one, we can just get rid of an additional dependency and make end users happier with not having that additional dependency. Well, turns out that was a reasonably good choice, but it has some quirks as well. The advertisement for System.Text.Json for years has been that it's a 100% replacement for Newtonsoft.json. Well, turns out it's not the case. There's a bunch of things in a table on the Microsoft Docs site where you can see that some things are not supported or require a workaround, etc. We have quite a bit of those workarounds in the Space SDK code generator. All in all, it's all doable, and you can easily extend System.Text.Json. But if someone tells you it's a 100% drop-in replacement, don't believe them yet. Speaking of this one, I'll give you a couple of examples of the converters that we had to write, actually. Probably one of the more important ones, or let's start with an easier one. Let's start with the enumeration converter. And I think it's going to be this one. Yes. So I showed you that in enums, where is that example again? We have these enum member values that are annotated there, right? Well, what we did was we, of course, had to write an enum string converter that would actually look at whether a type is an enum or not. And then if that is the case, look at those enum bindings and the attributes that was added. Turns out that something that is very easy to do in Newtonsoft.json requires a lot of codes in C# to actually get the value and translate things into the proper value that enum value attribute is showing. Not going into details on this one, but just to give you an idea of the hoops you will have to jump through. Another one that we had to write, or at least a couple that we had to write, were related to nullability. I think I have this one. Yes. So nullability in C# is something that is not really part of the type system. And that means that if you want to be able to write a converter that works for nullable, but also for non-nullable values, you will actually have to write two converters. Now, two converters definitely works, but there's another approach that you can take by writing a JSON converter factory, looking at whether the type is nullable or non-nullable, and then based on that, return the actual converter that is just a wrapper, for example, around the nullable version. So that's one that you will find in there. And then, another big one that you will find in there is one that does polymorphism. So a profile in space can be a person, for example, but can also be an automation user or an application. And all of those are modeled in the API as inheritance. There's going to be a base profile where user profile inherits from base profile, etc., etc. Well, we actually make use of a class name value there to determine which type we should serialize or deserialize into. And that's one of the other converters that we have in there. I invite you to look up the codes and see whatever is in there, because there's quite a few of them. And you may need them in your own projects at some point. Right, let's talk about developer experience. So why are we building this? Well, the idea is that people would ideally register an application in space, install the NuGet package into their projects, create a connection, and then start working without even having to read documentation. So there's a couple of things that our code generator is making happen, but also a couple of things in terms of utilities and so on that we added to make things easier to get started with working with space. So first of all, there's a large API surface, and you've seen that in the HTTP API playground, there's a theme directory with calendar events or birthday events, and then a method that you can call. Well, the hierarchy that you see in the playground is something that we want to preserve in our generated code as well. So if you in the playground see that you need access to theme directory, birthday events, get all birthdays, you will see that in code you also have a theme directory client with calendar events, birthday events, and then that method, just to make it easy for you to discover what is in there. Fields is another one. In that OpenAPI example, the idea was that you would have to give just a string of the fields that you wanted to retrieve in space. Well, in our .NET codes, or at least in the .NET SDK, we wrote it like this, where by default, if you want to get a member profile, for example, you will get all of the properties on that member profile. If you want to be specific and, for example, also get people's manager by getting a profile with an ID, a username, name, etc., you can actually do that by adding a builder object to build that entire string of fields that you want to retrieve. Maybe this also ties into that GraphQL question that I received earlier. This is how we do it in .NET. You don't have to pre-populate a string with what you want to retrieve and then generate some codes to actually generate the request object and so on. You, as a consumer of the SDK, are able to define what data you want to retrieve, and you can do it using a strong typed interface that does not require you to do additional things. I'll quickly show an example in code later on as well. Of course, I'll actually show it in code immediately. So if you go to our GitHub, you will find that in the project, I'm going to close this one because there's too much in there. There's also some samples that you can run. And the samples contain some of the examples of how you can work with the Space SDK. So I mentioned ideally you want to install the package and then create a connection, and then you can start working with Space. Well, that's exactly what we built. You can create a connection, register an application in Space, and from that moment you can start working with, for example, the theme directory clients. Using that one, you already know that using code completion, you will get access to all of those other sub-services that you've seen in the API playground. And for example, if I want to get all the locations in the company, I can go in there and then get all locations async and get that information back. You'll find that if you want to use the partial builder, you'll see that we can get, for example, all profiles with their ID and with their name. Maybe we also want to get with username or something like that. Again, by generating all of these helper methods, we make it easy for you to discover what fields you can actually retrieve if you want to retrieve a user profile. But you may also, at some point, forget requesting a specific field. Well, what we do in that case is give you very detailed information. Actually, what you will see, I'll maybe run this one until we hit this specific exception. What you will see, what you'll see is if we forget to actually get one of those properties, you will see that the Space SDK tells you which specific query or which specific calls you have to add into your code as well. So you'll see I'm getting profiles with just their ID. If we run this, I expect an exception when I access the first name and last name, and you'll see that there's now a property not requested exception. And if we look at the details of it, it will tell us exactly what to do. So here's the exception. You'll see that the property name was not requested. Add with name to your request to get that specific property. This is one of the things that you can also disable, because ideally you don't want to have accidental property not requested exceptions in your production application, so you can disable this if you want. Ideally, my big dream is to write an analyzer at some points to do this at code time or at design time and not at runtime, but we're not there yet. But that's the ideal thing that we want to do. There's a couple of other things in terms of developer experience that you may want to also build into the SDKs that you are building. A lot of the endpoints in Space give you back batches of information. If you have an organization with 1,000 employees, if you get all profiles in the organization, they will be paged by 100, I think, by default. What do you do if you want to get all of those pages? Well, you could use the default generated code and get all to-do items as a batch, and then for every batch page, get more pages and more data and so on. This felt a little bit awkward, so we decided to write or generate some IAsyncEnumerable options to also give you a nicer way to just be able to, for each over to-dos, for example, in this case, get all that data, and behind the scenes Space or the Space SDK will get that information for you. That also has one downside. So I mentioned that we're trying to focus on developer experience. If we give you an enumerable to get all to-do items or all profiles and things like that, there's probably also going to be folks who do a .count or a .any or a .whatever, which means they will be getting all of the profiles from their Space organization. That's, of course, not intended. So for those, you will actually have to read the documentation, because for those, we actually have a hint where we say, okay, get the first batch, because the first batch will also have the download counts or the total number of results in there. Cool. Quick example of how this works. Actually, I have it here. We can get all profiles using an IAsyncEnumerable. The generated code for this one looks like this. It's essentially a one-liner that pipes its request into the batch methods that we have, that gets a batch of member profiles and does everything that is in there. What it does is it wraps that in a batch enumerator.allItems. And what this thing is doing is essentially this. Let's minimize some stuff here. It will enumerate everything that it can retrieve using a batch response. So what it will do is enumerate all of the pages, which is happening like this, and that's essentially the codes that I had on the slide if we were to do this manually. It will fetch all pages, and for every page, it will then enumerate all results and return those results. Nice thing of this approach is that we are still using paging, but you as an end user don't have to care about it. In fact, if you only need the first 110 results from profiles, well, you will essentially fetch 2 batches of pages from Space, but you don't realize, you don't have to know about this. You will only get 2 because we're still enumerating things. If you exit that for each, we will break, and the IAsyncEnumerable will also break. Right. Another thing that we're doing is flattening all of the request bodies that are there. In the OpenAPI slide, I think I mentioned that you could have, you could generate based on OpenAPI a method that takes a body with request parameters and so on. We decided to flatten that and take all of those properties from that object that you essentially have to send into the API, flatten that into just parameter values that are in there. What we're also doing is creating factory methods for inheritors. Again, something to help you discover things. You can send a chat message, for example, in the Space SDK using a .send messages async, and then add a channel, and then a channel from name, and then pass in the name. We actually made it nicer where you can say message recipients.channel, and code completion will already give you information about what you can do with that. And that's actually really, really powerful if you want to work with that. Show that as well. So in our program, if we want to send a message, I mentioned that everything in Space can be a chat. So if instead of sending this to a channel, I want to send this to an issue, well, you will see that message recipients dot has issue. And I can specify an issue from name, for example, but if I use a member, I will get code completion that gives me a profile identifier, and that profile identifier can be me or a specific profile ID and so on. So we generate those helper methods essentially to make it easier for you to discover what you can do in terms of sending a chat message, in this case to yourself or to a specific ID or a username, etc. And I'll again undo that so I don't accidentally commit after this talk. Default values is another thing that we're doing. So getting absences, for example, like you see on the slide here, has an option where you can specify how you want to list absences. Do you want just vacations? Do you want all absences like business trips and things like that? There's a default value that Space will apply. And we decided, okay, maybe we should not bother you with having to specify that value again and again and again if you're just going to be using the defaults. So what our code generator is now also doing is providing all of those defaults for those types of parameters. Those are shown in code completion as well, or if you hover over the method name, you will see what the default is, again, giving you discoverability. The only thing that we're currently still missing is that this only works for primitive types, for strings, and for enums. And it would be cool if in C# we were able to also specify other object types, but that's not there yet. Right, so in conclusion, and I know I rushed a little bit over a couple of those things, but again, the goal of this talk was to give you some ideas of what you could do in your own SDKs that you may be building. In conclusion, we've quickly seen Space, really quickly. We've seen that there's an HTTP API to expose everything that is in there, do everything that you can do using the UI. And we wanted to build a .NET SDK to make it easy for you to be successful building your own integrations. We do that using code generations, lots and lots of custom converters in System.Text.Json. And if you're ever building an SDK, use it, build samples, build whatever you need, because that will highlight what developer experience you need for people to discover whatever is in your SDK. And again, using code generation, we're also able to generate a couple of those utilities that you might want to expose in the SDK. With that, I think we can wrap up. Thank you. If you want a written version of this talk, it's on my blog, which you can see the full URL or a very awkward short URL. And yeah, if there's any questions, I'll see them in the Q&A.
Thank you, Maarten, for your presentation.
Happy to do so. Nothing coming. This is one of the awkward things about presenting remotely, where people have to actually type their questions and you have to do what I'm doing now, just keep talking until people press enter and the question pops up.
I mean, Maarten, I can make it less awkward for you. You know, here, I'll ask you a question. This is Khalid, by the way. I'll turn on my camera. So I know you mentioned, you know, we went strings all the way, SDK. What was it about source generators that maybe wasn't the right fit for the Space SDK?
That's a very, very good question. And actually, if you, so it's on GitHub, github.com/jetbrains/space.net SDK. There is a branch, public even, mb.net source gen. I'll actually check out that branch to give you an idea of what it looks like. It's easy to work with source generators in this case. And we actually, yeah, everything will break now because I switched branches. Where is it again? Right, we have our program and there's going to be a source generator as well. There it is. All right. So what we did was actually write a C# source generator that does essentially everything that we've seen from the command line application that we built. So what it will do is it will execute async, small wrapper to make it async, because by default code generators in C# are not. What it will do is load our model from a file in this case, which is not there. So again, this branch will not 100% work, and then generate code exactly the same as we did before. Now, the downside of using source generators for this is that we, as a vendor, want to provide this to our users. So a source generator is really shipping the generator to people to use. And it might make sense for them if they have different versions of Space, et cetera, to generate one specific for their Space organization. But ideally, we want to pre-ship or ship pre-generated binaries. And we could still do that using source generators and just generate this once during RCI and ship all of that in the assembly that goes out. But in terms of debugging, in terms of troubleshooting generated code and so on, it's just a big hassle. So I hope that answers the question.
Yeah, thank you. It was a great answer. Thank you.
All right, no more questions, I guess.